A rectangular block, rectangular, that's a keyword, of a density given to us, has sides 12, 15, and 10 cm. What's the maximum pressure this block can exert when resting on a table? So, we have a block. Now, no diagram is provided to us, which means we should draw a diagram. This is true for most chapters in physics. If there's no diagram, you must draw your own diagram. So, I cheated and I created in my PowerPoint. So, here's an example of the block. Ta-da! So, do you think this is the maximum pressure that this block can exert? Probably has a fixed mass. In fact, let's find the mass of this block. So, the mass... they didn't give mass. How to find mass? Wait, we can find volume. We have density. So actually we can find mass. Because, way to squeeze. Top right. Density is mass per unit volume. So mass will just be density times volume. Hey, so we can find. So mass will be density 1.13 times 10 to the power 4 times the volume. It's in cm. Make sure you change to meters. So you have 0.12 times 0.15 times 0.10. That will be your mass of this block. So calculate and see what do we get for the mass of the block. I got about 20.34 kg. Okay, so means if this is on a table, this is a 2D picture, so imagine a table is like that. You have a weight which is m times g. Okay, so is this the maximum pressure? That's it. Just P equals to F over A. P is, the force is weight, so mg over A. That's it. Hang on. Maximum pressure. This block can rotate one, right? So I can say it's lying down like that, or it could be like that, or it could be like that. Which one do you think will cause the will exert the maximum pressure on the table? Orientation A, B, or orientation C? If you guess C, that is correct. Why? Because of the cross-section area. What is the area touching the table? So for the first one, I'm going to say the shortest length is 10, so this is 10. Second shortest is 12, so this is 12, 15. This one, the cross-section area is 12 times 15 cm. For this one, it will be 10 times 12 times 15. It'll be 150. But for orientation C, if it's standing upright, you have 10 times 12 times 15 cm squared. So actually C is the one that will have the smallest area and therefore the greatest pressure. P largest. How I know that? I haven't calculated, but I based on ratios. P is F over A. If your A is small, means the pressure is larger. It's using ratios. Okay. So now we can actually calculate it. So let's see. The mass we calculate was about 20.34. Or if you want to calculate everything one shot in your calculator, also can. So 9.81 gravitational constant divided by the area down there. So that will be 0.12 times 0.10. Okay, what do we get for our pressure? You write down here. Calculate. You should get about, in the kilopascal range, so about 16.6 kilopascal. Kilo because it's actually like 16653 or something like that. But don't want to write so many, so just kilopascal. Convenience sake. So this is one way we can do it. Break down every step and find the pressure. Now I'm going to show you a shortcut which is related to the next bit of what we're going to learn about pressure in fluids. So the shortcut is this. If you don't want to do so many steps, you want to do everything at one go, can. You just remember some key formulas. So firstly, pressure is force over area, right? So force will be mass times gravitational constants over area. And just now we established in the top right corner, we can use density and volume to find that. So plug in again. So let's sub in density, volume, gravitational constant divided by area. And actually we can shortcut a bit more, because volume is actually area, cross-section area of the bottom part, times the height, times gravity over area. Oh, so area cancel out. Oh, area. So all that's left is just P equals to rho Hg, or rho GH. Rho GH sounds nicer. Rho GH. So this one, if you want to shortcut to find the pressure, you just take the density of the block, 1.13 times 10 to the 4 times 9.81 times the height. What's the height? Height is this one, because cross-section area is the bottom, so height is just 0.15. By using this shortcut, you can also find the answer, 16.6 kilopascal.